Hello viewers, welcome to the lecture series of SSC Quantitative Aptitude. This is your tutor Keshav Agarwal and this lecture on LCM and HCF. So in this lecture, we are going to see 25 questions on LCM and HCF. Let us start with the very first question. What is the least value which should be added to 1812 to make it divisible by 7, 11 and 14. Let us have a look over the solution. So to find out which number should be added to 1812, we are going to first of all find out the LCM of 7, 11, 14. So the LCM of 7, 11, 14 is 154. And when we divide the given number 1812 by 154, we are left with remainder 118. So therefore, the required number is 154 minus 118, that is 36. So the correct option here will be option number B. Now, moving on to question number 2. The HCF of two numbers is 21. So the HCF is given to us and their LCM is 221 times the HCF. So a relation between HCF and LCM is given and HCF is already known, so we can obtain LCM also. If one of the numbers lies between 200 and 300, then the sum of digits of the other number is. Moving on to solution. We are provided with HCF and it is equal to 21. And it is also given that LCM is equal to 221 times of HCF, which is equal to 221 times of 221. So 221 can also be written as 13 into 17. So LCM includes common factors as well as extra factors. One number lies between 200 and 300. Therefore, the first number is 21 into 13. That means 273. And the second number is 21 and 17. That will be 357. So the sum of digits of the second number is 3 plus 5 plus 7. That is equal to 15. So the correct option here is option number D. Let us move to question number 3. The smallest number which when increased by 5 is divisible by 24, 32, 36 and 54. The solution: LCM of 24, 32, 36, 54 is given by 864. Therefore, the required number is 864 minus 5, that is equal to 859. Hence, the correct option is option number B. Let us now see question number 4. What is the least number of square tiles required to pave the floor of room 15 meter 17 centimeter long and 9 meter 2 centimeter broad? So dimension of a floor is given to us and we need how many square tiles are required to pave the floor. So length of largest tile is equal to HCF of 151 centimeter and 902 centimeter. So in this question, we have first of all converted this given length into centimeters and this length into centimeters. Okay, then we start solving because when we have complete number in the same unit, then the calculation becomes easier. Now, since the length of largest tile is known, so the area of each tile will be 41 to the power 2 centimeter square. Therefore, the required number of tiles is area of floor upon area of tiles. So, area of floor can be obtained by multiplying length into breadth. So, it will be 1517 times of 902 upon 41 into 41. And when you simplify it, you will get 814. So the correct option here is option number D. Question number 5. Find the least multiple of 7 which leaves the remainder 4 when divided by any of 6, 9, 15 and 18. So LCM of 6, 9, 15 and 18 is equal to 90. Let the number be 90k plus 4 which is multiple of 7. So at k equal to 4, the remainder is 0. Therefore, 90 times of 4 plus 4, that is 364, is the required number. Hence, the option correct here is option number D. Now, question number 6. What is the least number? What least number must be subtracted from 1936 so that the resulting number, when divided by 9, 10 and 15, will leave in each case the same remainder 7. Since the number should be divisible by 9, 10 and 15, leaving the remainder 7 in each case, thus a remainder 7 will also be obtained when it is divided by LCM of 9, 10 and 15. So the LCM of 9, 10 and 15 is equal to 90, and when you divide the given number 1936 by 90, we get quotient equal to 21 and remainder equal to 46. The remainder should be 7, thus the least number which should be subtracted from 1936 is equal to 46 minus 7, that is 39. So the correct option here will be option number C. Question number 7. Find the greatest number of 4 digits which when divided by 3579 leave remainders 1, 3, 5 and 7 respectively. Solution. The difference between divisor and remainder is equal. So the LCM of 357 and 9 is equal to 315. So largest 4-digit number is 999. Okay, so after that it becomes 5-digit number. So dividing 999 by 315, we get quotient equal to 31 and remainder equal to 234. So therefore the number divisible by 315 is equal to 4 nines minus 234, which is equal to 9765. That means 9765 is divisible by 315. Therefore, required number is equal to 9765 minus 2, that is 9763. Hence, the option correct here is option number A. Question number 8. Let x be the least number which when divided by 5, 6, 7, 8 respectively leaves remainder 3 in each case, but when divided by 9 leaves remainder 0. Find the sum of digits of x. Solution. LCM of 5, 6, 7 and 8 is equal to 840. Hence the number can be written in the form of 840k plus 3, which is completely divisible by 9. If k is equal to 1, number will be 843, which is not divisible by 9. If k equal to 2, we get 1683, which is divisible by 9. Hence, 1683 is the least number which when divided by 5, 6, 7, 8 leaves remainder 3. But when divided by 9 leaves no remainder because 1683 is divisible by 9. Therefore, x will be equal to 1683. But in the question, it is asked to find the sum of digits of x. So x is equal to 1683. So the sum of digits of x is going to be 1 plus 6 plus 8 plus 3, that is equal to 18. Hence the correct option here is option number D. Question number 9. Find the number between 1000 and 2000 which, when divided by 30, 36 and 80, gives a remainder 11 in each case. Solution. So the LCM of 30, 36 and 80 is equal to 720. Hence the number is of the form 720k plus 11 because 11 is the remainder in each case. So if we choose k equal to 1, then the number does not lie between 1000 to 2000. It is less than 1000. So if you choose k equal to 2, then you get 1451, which lies between 1000 to 2000. Hence, which option is correct? Option number B. Question number 10. A number x is divisible by 7. When this number is divided by 8, 12 and 16, it leaves a remainder 3 in each case. Find the least value of x. LCM of 8, 12 and 16 is equal to 48. Therefore, required number is equal to 48k plus 3, which is divisible by 7. So, for x is equal to 48k plus 3, and it can also be written as 7 times of 6k plus 6k plus 3. And if you break it down, it will be 7 times of 6k plus 6k plus 3, and this is divisible by 7. That is, 6k plus 3 is divisible by 7. And when you choose k equal to 3, you get 21, which is divisible by 7. So, for x is going to be 48 times of 3 plus 3, which is equal to 147. Hence, the correct option here will be option number D. Let us move to question number 11. The sum of two positive numbers is 240 and their HCF is 15. Find number of pairs of numbers satisfying the given condition. The sum of two numbers, positive number, is 240 and their HCF is 15. Let two positive number is 15x and 15y. According to the question, the sum of number is 15x plus 15y equal to 240, which means x plus y is equal to 16. Now we have to find number of pairs in which sum of the two number is 16 but no common factor between them. And such pairs are 1, 15, 3, 13, 5, 11 and 7, 9. Therefore, number of pairs satisfying the given condition is 4. So, correct option here will be option number D. Question number 12. The HCF of two numbers each having 3 digits is 17. Okay, so HCF is given and their LCM is 714. So find the sum of numbers. Let the number be 17a and 17b because it is known that their HCF is 17. So the number must be of the form 17a plus 17b, where a and b are co-primes. So LCM is equal to 17ab. Now 17ab is equal to 714 because LCM is also given to us. So when you simplify this, you will get AB equal to 42, which is equal to 6 times 7. That means A equal to 6, B equal to 7, or A equal to 7 and B equal to 6. One of these possibility holds. So the first number is 17 into 6, which is 102. And the second number is 17 into 7, which is 119. That means sum is 102 plus 119, that is equal to 221. So the option correct here is option number C. Let us move to question number 13. The product of LCM and HCF of two numbers is 24. The difference of two numbers is 2. Find the number. So it is given that LCM into HCF is equal to product of two numbers. Okay. So LCM into HCF is equal to XY, where X and Y are two numbers that we are looking for. So XY is equal to 24. This information is given to us, and it also gives that given that X minus Y is equal to 2. So by solving the above equations, you will have X equal to 6 and Y equal to 4. So the option correct here is option number D. Question number 14. The LCM of two multiples of 12 is 1056. If one of the number is 132, find the other number. So solution, HCF is equal to 12 and LCM is equal to 1056. So one of number is 132. So we are interested in the second number. So LCM into HCF is equal to product of numbers. And let us suppose the numbers be X and Y. So it is going to be 132 into Y equal to 12 into 1056. That means Y can be easily obtained by solving it, and you will get Y equal to 96. So the option correct here will be option number C. What is the greatest number which will divide 110 and 128, leaving a remainder 2 in each case? Solution. Required number is HCF of 110 minus 2 and 128 minus 2. That means HCF of 108 and 126. So 108 can be written as 2 square into 3 cube, and 126 can be written as 2 into 3 square into 7. So HCF is going to be 2 into 3 square, which is equal to 18. Hence the option B is correct. Question number 16. When 7897 and 8110 and 8536 are divided by greatest number x, then the remainder in each case is same. Find the sum of digits of x. The solution, let remainder be k. That means 7897 minus k equal to ax, 8110 minus k equal to bx, and 8536 minus k equal to cx, and where x is a common factor. So the difference between the numbers is 8110 minus 7897 equal to 213, 8536 minus 8110 equal to 426, and 8536 minus 7897 is equal to 639. So HCF of 213, 426 and 639 is equal to 213. That means x equal to 213. If you take the sum of digits, you will get 6. So the correct answer is 6. So option correct here is option A. Find the greatest number by which 2300 and 3500 are divided, leaving the remainder 32 and 56 respectively. So 2300 minus 32 is equal to 2268, and 3500 minus 56 equal to 3444. And the factors of 2268 is equal to 2 times 2, 4 times 3 and 1 times 7. And 3444 is equal to 2 times 2, 3 1 time, 7 1 time, and 1 time 41. So HCF of both numbers is equal to 2 and 2 into 2 into 3 into 7, which is equal to 84. Hence, the greatest number which divides 2300 and 3500, leaving 32 and 56 remainder as a remainder is 84. So, the option correct here is option number D. What is the LCM of 8x cube plus 8x square plus 200x and 4x to the power 4 plus 16x cube minus 20x square? So let us see the factors of 8x cube plus 80x square plus 200x, and that is equal to 8 times of x square plus 10x plus 25, which can be written as x square plus 2 into 5 into x plus 5 square. That means it is nothing but x plus 5 whole square times of 8. And if you talk about another number, this one, so 4x cube plus 6x cube minus 20x square can be written as 4x square common, taken out common, and you will be left with x square plus 4x minus 5. So when you factorize it, you will get 4x square into x plus 5 into x minus 1. And if you choose both of them and take the LCM, you will see you will have answer as 8x square x plus 5 whole square times of x minus 1. So the option correct here is option number A. Now question number 19. Find the LCM of 186.6 and 373.2. So solution. So LCM of 868 and 373.2, that is what we want to find. So 186.6 can be written as 186.6 into 1, and 372.2 can be written as 186.6 into 2. Therefore, the LCM is going to be 186.6 into 1 into 2 equal to 373.2. So the correct option here is option number A. Question number 20. A and B run 20-kilometer race on a circular track of length 1200 meters. They complete one round in 300 seconds and 400 seconds respectively. After how much time from start will the faster person meet the slower person for the last time? Solution. So total 12-kilometer race, that is 12,000 meter. Race in a circular track of length 1200 meters. So number of rounds to complete the race is 10. So they need to take 10 rounds to complete the race. So time taken by A to complete the first round is 300 seconds. Therefore, time taken by A to complete 10 rounds is going to be 3000 seconds. And when they both start running first time when they meet, LCM of 300 second and 400 second, that is equal to 1200 seconds. For the next meet, they will take 1200 into 2 seconds, that is 1200 into 2, that is 2400 seconds. And for the next meet, time would be 3600 seconds, which is not possible because A completes the whole race in 3000 seconds. Therefore, time cannot be more than 3000 seconds. Therefore, the faster person meets the slower person for the last time at 2400 seconds. So the correct option here is option number A. Question number 21. Else find the LCM of 3 to the power 4 into 5 square into 7 square into 11, 3 cube into 5 into 7 into 11 square, and 3 square into 5 cube into 11 to the power 4. So the solution. We have 3 to the power 4, 5 square into 7 square into 11, and another number is this one and this one. And if you observe them, you will see the LCM is 3 to the power 4, 5 cube into 7 square into 11 to the power 4. So the correct option here will be option number A. Moving to question number 22. Which greatest number will divide 3026 and 5053, leaving remainder 11 and 13 respectively? So required number is equal to HCF of 3026 minus 11 and 5053 minus 13. Therefore, HCF of 3015 and 5040 is 45. So the option correct here is option number C. Question number 13. What is the least number which when divided by 12 leaves a remainder of 7? When divided by 15 leaves a remainder of 10, and when divided by 16 leaves a remainder of 11. Here 12 minus 7 is equal to 15 minus 10, and it is equal to 5. Therefore, the required number is equal to LCM of 12, 15, 16 and minus 5. So it is equal to 3 into 4 into 5 into 4 minus 5, that is equal to 235. So the option correct here will be option number B. Now, question number 24. The ratio between two numbers is 2:3. If the LCM is 150, then the numbers are. So let us suppose numbers be 2x and 3x, and their LCM is 6x, and it is given that their LCM is 150. So we can put 6x equal to 150, and if you divide 150 by 6, you will have x equal to 25. So the numbers are 50 and 75, which can be obtained by just putting x here and here. So the correct option is option number C. Question number 25. What is the least number which when diminished by 5 is divisible by each one of 21, 28, 36 and 45? So required number is equal to LCM of 21, 28, 36, 45 plus 5, which is equal to 3 times of 3 times of 7 times of 4 times of 5 plus 5. So it is equal to 1265. So the option correct here is option number D. So thank you very much. That would be all for this lecture, and I'll see you in the next class with a few more questions on LCM and HCF.